Welcome, everyone. Think about something that you learned on Friday, and on Monday, you say to your boss that you can give me task on that particular topic. Docker is one of the things that we can learn on Friday and start working on that on Monday. And in this session, we are going to talk about Docker for the data engineers, environment isolation, its portability, and cloud native parity. So after this session, you'll get to know how we can work with the Docker, how we can work with the images, how we can utilize a third-party application in our container. And we'll after this session, we will and in this session at the end, we will have a demo session for that, and it will be connecting the front end with the back end, like MongoDB and the Mongo Express. So before starting, what is Docker? We'll jump to what is a container. So container is something that contains all of the dependencies and all of the packages that will be required to build an application. It can be of multiple, you can say application like MongoDB, Redis, Python, and other things. Okay, and multiple versions if needed, we can use them as well. The image shows that you can have web application, API service, and database in a different container, and they'll be isolated with each other. Okay, so if anything goes wrong in container A, it won't affect container B and container C respectively. A container is a lightweight standalone package that bundles an application with everything it needs to run. Okay, since it is lightweight, so it will be taking less time to boot up. It is portable. That means it can be ported from a machine. It can be developer, operations, or any of the team. Isolated, we already saw that how the systems are being isolated from each other, and consistent, it will be consistent of all of the machines. It will be working in the way it is working on a machine, it will be working on the same on the other machine as well. You just need to run a command docker run, and everything goes up on your machine as well. There is a myth around here that Docker image and Docker container both are same. It is, but there is slight difference between both of them. Docker image is the freeze code and the Docker container is the active cake. You can say the running state of the Docker image. Docker images has all the recipes, the Docker, the commands to pull the image, the ports that we will be having to bind it with the local host. Okay, and when we execute our Docker image, it will be taking the shape of a container. A container has its own, its application layer and the file system. So you can see a Docker image is in the rest of the state, and we'll do the Docker build. And once it is executed with the Docker run, it takes the form of a Docker container. It has its own process file system, views, and network. A thin layer and can be started and stopped independently. Now coming to the commands that we have in Docker, it is categorized into three categories based on the things that we have: images, container, and to debug and inspect these two. For images, there are a few commands like docker build images to build the image, to see the image, pull push from the registry that we have in Docker Hub to remove it from the local system. Similarly, for the container, we have our ps command to install the container, run command, stop command, start command to do the same, and the docker rm to remove the stopped containers. In the inspect, we have the logs inspect. There is one special command, docker exec it. It enables us to log into the container, and we can do the things. I'll wait for 5 to 10 seconds so that you can take the screenshot and note it down the required or the important commands. Okay. So let me show you one example of the images that we just saw. So this is our Docker Hub, the official page, and if we go and search for Redis, and this is the Docker official image for Redis. If we click on that, Okay, so you'll find that there are multiple versions of Redis that is available in here. Okay, and we can pull any of the required version that we needed in our machine. So let me show you one of them. If I do the Docker pull Redis, but I didn't provide any kind of tag in here, so you by default it will be using the latest tag, and it is downloading it in the form of a layer. Since the image is in the form of a layer, and it will be downloading only those things that will be required and different from the parent command. Okay. But on the other hand, we can go for another version. Like if I want to work with the 8.4.5, I can specify it Docker pull Redis 8.4.5 and press enter. So it will be downloading only those layers that are different from the parent layer, the latest one. And it will be pulling only that specific version that we provided in the tag 8.4.5. So if we come here and check our previous command Docker pull Redis, the pull is complete. And if I execute Docker images, it will list down all of the images that we have in our system. So you can see we have our Redis latest. This is the command. This is the version that we have. And we can use Docker run and the image ID. And if I enter it, you can see it is ready to accept the connections. Okay. And there are a few more things that you can see in here in the logs that this is the Redis version 8.10.0, and it will be listening on port 6379. We can validate our Docker if we have everything or not. See, this is the container image that we just created 33 seconds ago. It will be listening on the same port that we just saw on there 6379. Okay, so these are the few commands that we can make it working. Okay, and suppose if I log into container, the same container that we have. So what I'll do, Docker exec, there's one tag IT and the container ID. After the container ID, I'll put the path. So you will see that we are directly jumping to the container and we are under the data directory. And if I came out of it, now we are under the root directory. If I do some sort of ls or other commands, so it will be giving the same output that we have in our PowerShell. Okay. And we can play around it. We can do multiple things around it. env is something that will show you the configurations of this container. It is a Redis version 8.10.0. These are the paths. And yeah, that's how it is. And if you want to come out of it, just type exit and we are out of the container. So let's get back to our slides. Yeah. So what the Docker is solving? This is the main question. In traditional software deployment, if you see that there are some certain steps that we used to follow, right? Like write the code locally, okay, and testing it locally and provision it. We have a server that is already running. We upload the code on that server, configure it manually. But the same thing doesn't work there. And usually the engineers will came to know that, okay, the code is working on our machine, but it is not working on the server. And there is nothing they did wrong on their end. They did everything whatever they have, but just because of the software and the OS incompatibility, it is not working on the server. This is the same thing the Docker is solving for us. The software crisis for data engineer. So this is the same thing that I just showed, that I explained you, that the breakpoints could be anything varying local runtime environment. For example, our local machine is on Python 3.11 and the server is on Python 3.8. We are missing some kind of libraries that will be needed on the server and some of the mismatch that will be breaking the API structure. So there could be any reason. But if you do the same thing with Docker, there is no chance that it will be breaking because you'll be isolating everything in a container. So there is nothing outside that. The nightmare of the environment drift for any kind or for any developer or data engineer. The environment drift, it occurs when a script run locally perfect on a developer's laptop but fails immediately inside its staging or production environment. So this is the same thing that I explained to you in the previous slide. This is the software crisis and this is the nightmare drift. There are few things that are available in the market, virtual machines. So why should we opt for container? Everybody thinks that if there are virtual machines, why should I opt for container? Yes, we have the virtual machine that do the same thing, but containers are quite ahead of that. Virtual machine works on the application layer and has its own OS system, but the container is working on the local host kernel and works only on the application layer. That means it is taking less memory, less time to boot up, and can work very fast. The shipping analogy with the container is the main, you can say, the main point of benefit for the developers, because the code that will be working on my machine is going to work the same way on the operation team or the testers and everything. But if we go to the traditional approach, everybody has to install the applications. Okay, every kind of database configurations, everything has to be matched. Else it will create a kind of chaos that the application would be working on the developer side, but not working in the operations or the testing. The main three pillars of Docker are the Dockerfile, the Docker image, and the Docker container. Dockerfile, you can say the recipe that lists everything, whatever the Docker is needed to run a container. The Docker image, the static snapshots, you can say image that we will be communicating with the Docker hub or the Docker registry, and the Docker container, the running state of the Docker image. What is a Docker daemon? It is basically the architecture of the Docker is compiled with three states: the Docker client, the Docker daemon, and the Docker registry. Docker CLI, ask, if you say that whenever we are writing any kind of commands related to Docker, it will be a Docker CLI. We can execute run command, ps command, list command, stop command, start command, and it will be gone to the Docker daemon. Docker daemon will be responding to the same command that we have. So in terms, you can say Docker daemon is the brain of the Docker. It is responsible for allocating the space, allocating resources, manage and network volumes, push images from the registries, whether it is a public repository or whether it is a private repository. And we can pull and push images from the registry. It can be Docker Hub or AWS ECR. Again, the client server architecture, we already gone through the Docker client, the Docker daemon, and the Docker registry. There is one more known registry, AWS ECR, that is used to store the images. The layered union file system. In the terminal, we just saw that when we downloaded when we pull the Redis image, it is downloaded in the form of layers. So every image is a kind of a layer that will be downloaded, and we just need to, and whenever we are trying to pull any previous version or any other version, it will pull only the like the different layer. It won't pull all of the layers by itself. It will pull only the different layer. So it will be taking less time comparatively to other things. Yeah. There is one demo I prepared for you. So this is the basic Docker file. that should be having a dependent in a third-party application. In this, we have Python 3.11. We are using the Slim version. This would be the working directory, and we are using the run command to install all of the dependencies. Pipeline.py is the main file that will be having all of the code that will be written in Python. And CMD is the entry point that will be printing Python and pipeline.py on the command shell. Docker build and Docker run are the commands that are used to run and build the Docker. Now let's jump to our project. So this is the project. So here we are working on the node on the 13 version Alpine. These are the environment variables that we set: MongoDB username and the password. To log into MongoDB, we will be needing admin username and the password. Working directory would be home and application, and it will copy all of the things in the app directory from home app, and it will install the running dependencies that we have, and it will execute server.js, and it will be printing node on the terminal. Okay, server.js, this is the JS file that will be communicating MongoDB with the front end. Okay, and yeah, there is one Docker compose file. Let me explain you what it is and how it is working. So from all of the services that will be used in this container, first is the MongoDB, second is the Mongo Express. What kind of image? The name of the image would be Mongo, and it will be communicating with our local host on port 27017. By default, MongoDB communicate on 27017, and we are providing the same port. Okay, but in Mongo Express, I have configured a different port. It is working on 8080, but the default tag is 8081. So I binded it with a different port. The environmental variables, username and password to log into the MongoDB, and to keep the data persistent, I have attached one volume that will be under this directory, data db, and to make it working for the MongoDB, Mongo Express should know the things that this is the admin and the password, and if the password and the username matches, we will be able to connect to the MongoDB. And again, this is the Mongo drivers and the volumes. So I have already executed those commands to do the Docker build and the other things. Let me show you. So you'll see that there's one front end that is open for port 3000, and our MongoDB, the local host, that is working on port 8080. Okay, so this is the database. Sorry, this is the front end, and this is the MongoDB Express. So if we create any kind of database, suppose if I do MyDB and create a database, we just created a database, and if I go on MongoDB, MyDB, and create one user, create one collection. So you'll find that we don't have any data in that. Okay. Why we did only create with this MyDB end user? Because in our code, we have already classified that the database name would always be MyDB, and the collection would always be users. Okay. And in the logs, if you check, yeah, so that's why we put the same name. And if I go on to the front end and do any kind of changes in there, it's Ksolves India, Ksolves, and the interest is Docker. And if I update my profile here, so you'll see that the changes are visible in the front end. but will the same changes will be visible on the backend? If I refresh this one, so you'll find that we have one entry. And if I click on the here, you will see that all of the things that we have updated on the front end, the same thing is available in the backend. Email ID, Ksolves, interest is Docker, the name is Ksolves India. It is not like that if I stop the container, the data will be gone, because we attach the volumes to that container. So the data will be persistent and the data won't get lost if the container is stopped. Okay, so this is the demo, and let's get back to the slides again. Yeah, so data persistence via volume. If we mount any kind of local directories or volumes in that, the data will be persistent, and that's how you can attach volume directly with the command shell. But since we used the Docker Compose file, we will be going to write in that way. Okay. There's something that it doesn't do, like it doesn't work with the DAG programs. We need some kind of runners to make it working with the DAG, like Airflow and the other DAG stuff. But yeah, it is quite it is this is the advantage that we can make it use of that. It has the zero dependency between conflicting pipeline schedule. We can schedule multiple pipelines. Okay, it will be working in the isolated system, so zero dependency on that. Okay, some of the best practice for the production: always use a slim image, just like we used for Python 3.11 slim. It minimize the container size, and it will just uh, create the container quite quick. And build a Docker ignore manifest and put all of the environment variables in that. Never put any kind of secrets in the Docker file. If we look on our project, we have one git ignore file, so it will be ignored during the GitHub actions. And there is one readme I've created for you also. You can go through what the project is doing and what are the commands we can create, and how we can do it in a different way. If I need to start the MongoDB from the very itself without any container or something, without any prior Docker Compose file, we can do that way. Same for the Mongo Express. Okay, so that's how you can go through with the README section. Yeah, and so after this session, we'll get to know what the Docker is, what are the images, what is the container, stopping a container, starting a container, debugging a container, log into the containers, checking the directories, how it is working in isolation. It is portable and gives good benefit uh, across the multiple teams, how volumes are get attached and keep the data persistence, containerization, everything in a single zip file, and move it around and push it to the Docker Hub directory or the AWS ECR. So yeah, that's it from my end. Thank you.